Okay guys, today is 2.4. We're doing limits approaching infinity. Okay, let's just start out with the warm-up real quick. We're going to look at some limits. Now notice this is not limits approaching infinity, it is limits approaching some number, some constant, okay? If you have a limit approaching some constant, that's what we were talking about last week, or the last lesson. Let's just go over this. For limits to a certain number, it could be an easy problem where you just plug it in, right? If there's no discontinuities, you just plug it in, you get an answer. Or you could have a hole, messing it up so you need to factor and cancel. And remember, factoring and canceling cancels out the removable discontinuity, the hole. Or lastly, you might have fallen on a vertical asymptote, so you need to plug into both sides to find the limit. Yes? Remember, on that, your answer will either be infinity, negative infinity, or does not exist. Let's go to the next slide. Okay, this is just a beginner one here. It's going to be used to talk about limits to infinity. So, ignore that line that I just made. Let's do the first one here. Limit as x approaches 3. Okay, so that would be this line right here. Limit approaching 3. From the left-hand side, it looks like we're approaching the y value of 1. From the right-hand side, we're approaching the y value of 1. So the answer here is 1. Okay, let's do limit as x approaches positive infinity. Okay, that's going to be way over here. Positive infinity is way over here. What y value are we approaching as we go way over here? Well, it looks like the y value this function is approaching is a half. So it looks like our limit is going to be a half. Okay, the limit as x approaches negative infinity. That's going to be way over here. Well, it looks like this function is also approaching that same y value of a half. So our answer here is going to be a half as well. Okay, now what we're going to talk about right now is the limit as x approaches infinity or negative infinity. What is it that we're looking at? How did we determine these answers? Well, if you look at what we determined to figure out those answers, it was this dotted line, right? And we call that dotted line a horizontal asymptote. So, on this, if you notice, a limit as x approaches infinity or negative infinity will be determined by horizontal asymptotes. And horizontal asymptotes, I taught you guys a way to determine a horizontal asymptote, and that was Bobo, Botza, eats DC. Okay, and let's go over what that means again. Bigger on bottom, y equals 0. Bigger on top, slant asymptote. Exponents are the same, divide coefficients. So if you ever see a limit to infinity or negative infinity, automatically use this. And let's do a couple of these so you guys can get a refresher on it. Okay, this is what we already spoke about. We were looking at horizontal asymptotes. Okay, let's do one more here. If you notice, this is a slant asymptote on this one. Whoops. This is a slant asymptote. And let me show you what would happen if you have a slant asymptote. So, x approaches negative 3. The answer to that one would be, well, it looks like that lies on the vertical asymptote, and the left-hand side approaches positive infinity, and the right-hand side approaches negative infinity. Therefore, there would not be a limit, because they do not approach the same thing. Okay, let's do this one. The limit as x approaches infinity. So way over here at infinity, looks like our value, our function, is continuing to go straight down. So that would mean as you go way over here to the right, you are getting a value of, a y value of negative infinity. Okay, now let's do this one. As x approaches negative infinity, as it goes way over here to the left, what y value are we approaching? Well, it looks like as we go way over there, we're using this function, and it's just going up. So in this case, it's positive infinity. So whenever we have a slant asymptote, so whenever there's a slant asymptote, okay, that means our answer will either be infinity or negative infinity, okay? And that determines if it goes down or if it goes up. So let's do a couple of these problems here and we'll get you guys done. Okay, remember when doing these, I see, okay, first thing I see here is I have a limit as x approaches negative infinity. Okay, so that means I am automatically using Bobo, Botza, eats DC. Okay, remember this means we are talking about the exponents, right? The exponents. So look at the largest exponent on the top. Looks like our largest term is the fourth. Look at the largest exponent on bottom. Our largest term has a 3. Okay, circle those. This is how I'm going to do these. Circle the largest terms. Okay, now is it bigger on top, bottom, or are they the same? In this case, it's bigger on top. So we are using Botza. Okay, remember, Botza has a slant asymptote. So that either means, it's going to be similar to what we were talking about in that last thing, that either means our function will go up as we go to the right, or go down as we go to the right. But in this case, we're talking about to the left because it's negative infinity. So it's either going to go down, or it's going to go up. Yeah? And we just need to determine, is this answer going to be positive or negative infinity? So what you're going to do is you're going to take your two largest terms, and you're just going to plug that value into here, and we're just going to look at the sign to see if it goes up or down. So this is 3 negative infinity to the 4th power over 2 negative infinity to the 3rd power. Okay, on top, negative number being raised to the 4th power. Okay, anything raised to an even number makes this positive. So this is a positive number multiplied by a positive number. That's a positive. Okay, on the bottom, we got a negative number being cubed. That keeps it negative. Times a positive, that keeps it negative. So positive divided by a negative is negative. So as we go to the left-hand side, here's going to be a little idea of the graph. As we go to the left, the graph is going to be going down. Okay, so our answer here is negative infinity. Okay, let's go to some more of them. Okay, so I see here that I have limits to infinity. Okay, limits to infinity. So I automatically write on the top here, Bobo, Botza, eats DC. Okay, so look at your exponents. My largest exponent here is this 7x to the 4th. My largest exponent on bottom is this one right here. I'm going to circle them. Notice how I included the sign. This is a positive 7. Okay, we are bigger on top in this case. So we're going to do that same thing. It's Botza. Okay, so it's bigger on top. It is going to be a slant asymptote. That means I need to plug in negative infinity here to see what kind of slant I have. Is it going down or up? So I'm going to have a 7 negative infinity to the 4th over 5 negative infinity to the 3rd. It's very similar to the one we last did. Negative number to the 4th is positive times a positive is a positive. On the bottom we have a negative to the cubed. That's going to be a negative times a positive is a negative. Equals positive divided by negative is negative infinity. So as we go to the left-hand side on this function, the function is going down to negative infinity. Okay, let's do this one. Limit as x approaches infinity. Find the largest exponent on top and bottom. That would be the largest on top. This is the largest on bottom. Okay, exponents are the same. That's this one right here. Exponents are the same. Divide coefficients. Okay, the coefficients are 4 and 6, which we can simplify. And that's our answer. 2/3. You have a horizontal asymptote that is 2/3. So as it goes to the right and it goes to the left, the answer is 2/3. So this one could have been the limit as x approaches negative infinity, and it would have been the same answer. Let's go to the next one. Okay, we're going to do the limit as x approaches infinity here. Okay, my largest exponent on top is this one. My largest exponent on bottom is that one. Looks like it's bigger on top. So now I need to plug in negative infinity and see what we got here. So negative infinity cubed over 2 negative infinity squared. Okay, that's going to be negative times a positive is negative. That's going to be positive times a positive is positive. Okay, it looks like as we go to the left on this graph, the graph is going down. Okay, let's go to this one over here. Okay, if you notice, my largest exponent on top is this one. Now, this one, it's not giving me a value that I like. So what I'm going to do is I'm going to rewrite this so I have all my exponents as not in fractions. Okay, so let's do the sandwich method on this. I'm going to put this whole thing over 1. Okay, and I'm going to combine the top and the bottom, the breads, to make our new numerator. So it's going to be x squared minus 5x plus 2. And then on the bottom, we're going to have 1 times 1, okay, which is just 1. So our answer here is x cubed minus 5x squared plus 2x. Okay, well, we're going to do the limit as x approaches infinity. Well, if you notice here, the bottom has an exponent of 0 because there's nothing there. So it is bigger on top. And remember, we're just going to plug into the largest term. I don't need to worry about plugging into the bottom because the bottom is just going to be 1. So I'm plugging infinity into that. So infinity cubed would just be infinity. So in this case, as the limit is going to the right, the function is going up, yeah, and to infinity. So let's just review that real quick. We had a limit to infinity. We thought about Bobo Boats at East DC. We had to rewrite this one. We rewrote it. We got this. It is bigger on top, so there is a slant asymptote. So we had to plug in infinity into the largest term, and that gave us infinity. Okay. Next one here. We have limits to infinity and negative infinity. So that's going to be Bobo Boats Eats DC, right? Let's just figure out what it is we're using. Okay. Limit to infinity. Let's see here. Largest exponent on bottom is a 3. Okay, largest exponent on top is an x. Well, what is x in this case? If you look at it, x is infinity. So this number right here is infinity. So where is it bigger, on top or bottom? Well, it looks like it's way bigger on top. So that means that it's BOTSA. So there's a slant asymptote. So we need to plug in infinity and see what sign it gives us. Okay, so we got e to the infinity over, and remember we're just plugging into the largest terms, right? Just the largest terms. Infinity cubed. Okay, the top would be positive. E to the anything is positive, okay? And if you think about it, it's just because it's graph. This graph looks like this. So everything on e to the x, e to the anything is always positive. So this is going to be positive. A positive cubed is positive. So this is going to a positive, which is positive infinity. Okay, and there's the answer to that one. Okay, let's go over here to this one. Negative infinity. Okay, largest term on bottom is 3. Largest term on top is negative infinity. If you remember, negatives mean, a negative exponent means it belongs on the other side of the fraction. So really, this is supposed to look something like this. E to the infinity with infinity cubed plus 2 times infinity. So if you think about it like this is different. Where is it bigger, on top or bottom? Well, the exponent is much larger on bottom. The largest exponent is infinity. On top, it doesn't even have an exponent, so 0. So this one, the exponent is bigger on bottom. Bigger on bottom, y equals 0. So our answer is 0. I believe I have a graph here, so you can see a graph of this function. If you notice, they were both the same. Okay, let's do this one over here first. As we go to positive infinity, remember that's way over here. Oh, go back real quick. Remember that's way over here. And just to remind ourselves of our answers, it was infinity and 0. Okay, as we go way over here, it's going up, which means positive infinity. Now, if you notice way over here, as we go to negative infinity, like this one's telling us, you are approaching very closely, you are approaching 0. So the answer as you go way over there is 0. Okay, one last problem. This is the only time where the Bobo Boatsa kind of falls apart on us. It doesn't fall apart, it's just that your answer might be a different sign, okay? And that's going to be whenever you see this square root of something being squared. Now remember what the definition of an absolute value is, yeah? Definition of absolute value is the square root of some variable squared. That just means that everything's going to be positive that comes out of there. And that's where this is going to fail, okay? So if you ever see this or an absolute value, Bobo, it still works, it just might be a different sign, and let me show you why. Okay, let's first look at the graph and we can get our answers. The limit as x approaches infinity, it's way over here. Looks like our answer is maybe a half. Okay, y equals a half over here. As we go to negative infinity, as this one's asking us to, looks like our answer is a negative half. Y equals a negative half. Okay, now let's just see if we can determine these based off of a Bobo Boatsa eats DC. Okay, let's look at the largest exponent on top. The largest exponent on top is a 2, but it's being square rooted. So it's really like a 1, because those cancel each other out, yeah? And the largest exponent at the bottom is a 1. So we have exponents are the same, divide coefficients. So remember, circle your largest terms here. We're going to divide coefficients. The coefficient of this one is a 1. The coefficient of this one is a 2. So it looks like our answer is 1 over 2. Yeah? Now let's do the same thing over here. We see that the exponents are the same. We circle them. That gives us 1 over. Let me pause this real quick. Okay, guys, I'm back here. Let me try to remember where we were. We were talking about. I believe we were talking about this one. We're doing the limit. Okay, so we circled these, and we noticed that they had the same exponent. Therefore, you divide coefficients. That would be 1 over 2. Okay, and then we're working on this one now. We notice they have the same exponent as well. So we divide coefficients. So that would be 1 on the top there divided by that one, which is a 1 over 2 as well. So normally that would be your answer to both of these. But if you notice on this graph here, you have one that goes positive, one goes negative. And the reason why that's happening is that we have an absolute value in here screwing everything up for us, okay? So since we have an absolute value, what you need to do whenever you see that is that's the answer. That half is an answer. If you look at these answers that we got by the graph, the answer is a half. But it just might be a negative or it might be a positive. So what you want to do is you want to look at the sign. So plug the sign into here and just see what would it give you. Well, this is a positive infinity, so let's plug in a positive number into the top and bottom here. Okay, well, the top is an absolute value, so it's always going to give us positive. The bottom is 2 times a positive, which is a positive. So we have a positive over a positive. That makes this answer positive. Okay? This one over here, if you see it's a negative infinity, if you plug in a negative on top, that negative squared is going to make it positive, and then you square root it's positive. That's absolute value. That is a positive part. Now on the bottom here, if you plug in a negative, if you notice you get 2 times a negative, positive times a negative is a negative. So you have a positive divided by a negative, and as we know, a positive divided by a negative is a negative. So this answer would be a negative half. Yeah. So we only run into this problem if you see that square root of something being squared, if you see an absolute value sign, if you see something that might change the sign for either the numerator or the denominator. Okay, and that is everything for this lesson.